Hi, in this video, I'm going to talk about domain and range. You can read the definition of domain and range on this page. Basically, domain and range are all about value inputs, whether on the x-axis or on the y-axis. Okay, let's move on. Basically, there are two ways to determine domain and range of any functions, whether by looking at a graph or by looking at the function. Now let's look at how to determine domain and range given in graph form. In example 5, we have a linear graph. Top part of the graph is actually extending infinitely. Okay, it doesn't stop here. Okay, the same thing for the other end. That's why the domain is x all real numbers, and the same for range, where the value inputs that you can consider vertically will be y are all real numbers. Okay, the capital R here is actually real numbers, and the correct way to write real numbers R is this way, by writing double line for this. Okay, so this is real numbers. While this notation means element of. Element of. For this course, we will only consider real numbers only. And then in example 6, we have this linear graph, but be careful, the graph starts from a white dot. Okay, so the white dot is not the value input. White dot is not a value input. So the domain will be the value inputs that you can consider horizontally will be x greater than 2, because we have white dot. White dot mean it does not include 2. The same for the range. The value input will be y greater than 4. So here is x greater than 2, while for the range, y greater than 4. In example 7, we have two black dots. Okay, and you can see it already marked on the coordinate system. The domain will be all value input from 2 until 4. So black dot means include. Okay, so this is from 2 until 4. While for the range, it will be from 3 until 5. So you will write this as from 3 until 5. Now look at example 8. We have composite functions because we have two graphs on a coordinate system. Even though this is only single point, we can consider this as a graph. Okay, so what are the value inputs horizontally? Okay, since we have both black dot and white dot here, so this means include. This will the conclusion will be black dot. So you can the value input for the domain will be any value um, any value from -1 and below. So x can be any value less or equal than -1. But for the range, basically we will write y equals to 1, and another range will be y greater than 3, because for the top graph we can only consider any value greater than 3 but not 3. Okay, so that's why you have both values on the range. In example 9, we have 3 graphs. So to find the domain, we can actually connect these 3 graphs horizontally. Okay, we start at 0, and you can see that actually the graph is somewhat connecting until 3 but not 3. Okay, because for here we have black and white, so it will become black. And once again at 2 we have both black dot and white dot, so this is also become black dot. Okay, so the domain will be from 0 but not 3. From 0, x will be greater or equal than 0 but less than 3, because at 3 we have white dot. Okay, and then for the range, we will have y equal to 2, y equals to 4, and then y equals to 6. You can write here y equals to 2, 4, 6. In our final example, okay, for the domain, it will be greater than 4. So this is x greater than 4. Okay, and then for the range, this will be greater than 2 but stop just until 4, because you can see the graph only on this region vertically. Okay, so for the range, 2 less than y less or equal than 4. Or you can rewrite this in this bracket. The domain is x greater than 4. The range is y is greater than 2 but less or equal than 4. Alright, that's all for this video. I hope you learned something. Thank you so much.